I've already made a previous video explaining a couple of these. I just want to do a couple more right now with you guys in this period. So let's take a look at number 3. We need to be able to graph any quadratic function, especially those that are in standard form. We know that the most important point to any parabola is the vertex. So you need to have the vertex formula memorized. X equals negative b over 2 times a. And of course, when you use that formula, please rewrite it instead of b and a, put parentheses. That way you don't make mistakes. Of course, we're going to identify the a value is what? Negative 1. The b value is 4, and the c value is negative 2. C we don't care about, it's not in the formula. Okay, so let's plug in the b value of 4 right into that top parenthesis, the a value of negative 1 right down there. And what we have left is a negative 4 over a negative 2, which means that the answer is 2. But what is that answer really? What did we just find? We found x of the vertex, right? So right here where it says vertex, this is where they want us to write the answer for the vertex. Let's put 2 for the x. Now, a lot of students try to do this plugging in their head. I highly discourage that. Please take this answer and rewrite the whole function over again, but instead of x's, put parentheses. So instead of these x's right here, rewrite the whole thing, but with parentheses instead. That way you could take the 2 and plug them right into the parentheses that you just wrote. So let me rewrite it. Y equals negative x squared plus 4x minus 2. And I am plugging in the x value of 2 right in there. And you could use the Casio calculator and type it in exactly the way it is. I mean, with parentheses and with the exponent, exactly the way it is, and it should give you the y value. I like to actually work things out. Exponents first, 2 squared gives you 4. Of course, the minus sign comes right down and it becomes a negative 4. And then you have the 4 times 2, that's positive 8. And this minus 2, just bring it down. So from left to right, negative 4 plus 8, that's 4. And 4 minus 2 equals 2. So the y value of the vertex, that's what we just found right now. It says y equals, that's what it is, y equals 2. So the y value of the vertex is also 2. And that's always the most important So sorry, can't speak anymore. It's been a long day. The vertex is always the most important point when graphing a parabola. So let's graph that most important point to 2. 2 on the x, 2 on the y. You're right there. And almost like a reflex, after you draw your vertex, what should you draw? Axis of symmetry equation. On my videos, I always do a green dotted line. That provides us a reflection. It makes graphing a lot easier. It makes it twice as fast. That axis of symmetry equation, that vertical line, is x equals simply the x value of your vertex, which is 2. And believe it or not, that's what they're asking for right here. Look, the b, they're asking for what is the axis symmetry equation. You're going to write down x equals 2. So finding the vertex, easy. Just know the formula. Once you get that x value, plug it in to find y. You'll have your vertex. Draw your axis of symmetry right through that vertex. And of course, that's going to be the line x equals the x value of your vertex. Moving on, we need some points. We need some coordinates to be able to graph the parabola. So you either go for an XY table. So you could do this if you want. You could make a little input-output table right there. Or use the pattern. I always like to use the pattern. The pattern's 1, 1, 2, 4, 3, 9. And whenever I use this pattern, I always put it in a cloud because just this is what I need to have in my head memorized. It's a pattern from the vertex. This pattern came from the parent graph. But you could use a table if you want. So let's do both, all right? Let's actually entertain the pattern and let's entertain the table. So like an input-output table, how does that work? You can plug in any numbers you want for x, and you want to pull out answers for y. Now, obviously, you would like to plug in numbers that are on the same side, either the left side or the right side of the axis of symmetry. So what do you guys say? Pick the left side or the right side? Left is probably nicer because on the left side of this x-axis or x value of 2, on the left side is the value of 0. And 0 is the easiest number to plug in, right? when you plug in 0, especially into a standard form quadratic trinomial equation, if you plug in a 0 for x and a 0 for x, you're going to end up with the c value as your output, which is -2. So 0, -2, that's an actual coordinate. 0 on the x, -2 on the y, there it is. This is not a pattern, this is an actual coordinate. Now you could plug in as many other numbers as you want. You could plug in a 1 if you want. Now, if you do choose to use an XY table, I recommend showing your work. So right now that I'm doing this work in front of you guys, I'm not going to show my work. I'm just going to actually plug it in. You guys will catch my mistake, hopefully, if I do make it. So I'm going to plug in the number 1 right in here. All right, so 1 squared is 1. With the minus sign in front, that'll be a -1. So I have a -1 right here, plus 4 times 1, that's 4. So -1 plus 4, that's 3. And 3 minus 2 is 1. So when I plug in a 1, I get out a 1. I didn't make a mistake, did I? No? Okay, cool. So, of course, you could plug in as many numbers as you want. Let's go to the point 1, 1. 1 on the x, 1 on the y. So that is an example of using the XY table. Now, again, I prefer using the pattern. Even if I have to modify it, even if I had an a value of 2, I would modify the pattern before doing an XY table. But it is nice to know that the XY table always works on any function. Anyways, so if I go back to my vertex and I use the pattern 1 over and 1 down, because the a value is negative, I know it's opening down. So if I go 1 over from the vertex, 1 down, I get to that point right there. Let's all put a dot right there. And then you go back to the vertex, and you're going to go 2 over 4 down. So 2 over, 1, 2, 1, 2, 3, 4 down, you end up right there. And then you go back to the vertex and 3 over 9 down. So 1, 2, 3, 9 down, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right here. So as you can see, the pattern is a lot faster. And if you map it over to the other side of the axis of symmetry, you'll end up with those same blue coordinates anyway. So it's totally up to you if you want to use an input-output table, which it's nice, but the pattern's way faster. Okay. And if you did go get those blue dots using an input-output table, just map them over to get the red dots. Or from the vertex, use your pattern and then map them over to get the blue dots. Anyways, that's our parabola. We have a quiz, maybe a test this Friday, and you need to be able for sure to graph parabolas. If you can't graph parabolas, you're definitely not going to pass that quiz or test. You also need to state everything else that there is to state about a parabola. We already stated the vertex. We already stated the axis of symmetry. We even did an input-output table, or you could use your pattern. You don't have to use both. Pick one or the other on these exercises. How about the Y-intercept? Well, if you already graphed it, it's really easy to see the Y-intercept. Where does it cross? 0, -2. Now, let's say you didn't have it graphed and they asked you to find the Y-intercept value. All you have to do is set x equal to 0, right? And setting x equal to 0, we said was the easiest thing in the world to do when you have a standard form quadratic, because when you set it equal to 0, your c value will be your answer. So 0, -2 is your Y-intercept. One other thing, you need to be able to state whether it's a maximum or whether it has a maximum value or minimum value, and that all depends if it opens up or down, which is the a value, right? This a value is negative, which means that the parabola opens down. From left to right, it does go up, 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 and then reaches a maximum height, and then it comes back down. Make sense? So what is this? That's a max value. Okay, so we're going to circle max, and we're also going to state what that max value actually is. What is that maximum value? 2. So we're going to say y equals 2. You could say 2. You could just say the max value is 2. That's totally fine. 100% correct. You could say the max value is at y equals 2. You could even say the max value is the vertex itself, and you could just rewrite the vertex 2, 2. But the majority of the times that I've seen it on multiple choice tests, they'll write it as y equals 2, like the actual y value of the max or the min. Okay, what else? We have domain. Domain's cake, because it's always the same. X equals all real numbers. That's always true for any parabola. Range. Y, it's either going to be greater than or equal to, or less than or equal to, whatever your y value of your vertex is. Less than or equal to the y value of your vertex, which is 2. Bless you. Finally, State the x-intercepts. Approximate if necessary. So the y-intercept was pretty easy. Just look at where it crosses the y-axis. Now the x-intercepts, bless you, the x-intercepts, we have 0 here, we have 1 right here, 2 right here, 3 right here, and 4 right there. So where does a parabola cross the x-axis? At these two locations. What are those two locations? Since they're not nice points, we're just going to give a decimal approximation. About what? 0.5. About 0.5 and about 3.5, right? Or you could say like 0.6 and 3.4, whatever you want. I'm good with 0.5s. So what we do need to be careful with, if you're approximating, you must do the squiggly equal sign. Because if you put equals, it's going to be wrong because it's not exact. It's just an approximation. And what was that approximation? We said 0.5 or 0.6 and 3.5 or 3.4. Whatever you put is fine. Later on, next week, we will be able to find the exact values of these x-intercepts. But for right now, we're just going to do a decimal approximation. Okay. Now, some of them will be nice x-intercept values. Some you will approximate. Let's flip this paper over. Let's take a look at number 8. Why am I picking number 8? Because, well, the a value is not 1, so we're going to have to modify the pattern. Not only that, the b value is missing. It's not a trinomial, it's a quadratic binomial. That throws some students off, so I wanted to do this one with you guys. Like always, we're going to begin by finding the vertex using the vertex formula. X equals negative b over 2 times a. We're going to use parentheses instead of the b and the a. We're going to label our a, b, and c. The a value is 2, the b value is not there, the c value is negative 5. Remember, the b value is with x, and since there is no x term, I mean, technically you could rewrite it as 0x if you wanted to, but there is no b, the b is 0. Okay? So if you guys are totally confused, you could go ahead and rewrite it as 2x squared plus 0x minus 5. That way you could see, oh, my a value is 2, my b value is 0, my c value is negative 5. So when you plug in 0 for x and 2 for a, it doesn't matter if you have a positive 0 or a negative 0, it's still going to be 0 up on top. And 0 divided by anything is still 0. Okay, so our vertex x value is 0, but we still need our y value. So how do we find our y value if we already know our x? Simply plug it in. So I would rewrite the above equation, y equals 2x squared minus 5, and plug in that 0 for x. 0 squared is 0. This becomes 0, and then 2 times 0 is 0. So you have 0 minus 5. That's just minus 5. So the vertex is really 0, negative 5. You know what? You could have also looked at this original equation and thought of vertex form. You guys remember vertex form? It's just an option. You could have looked at it in vertex form and said, oh, my h value is in parentheses with x, and it's being subtracted from x, so there's obviously no h value. And my k value is the number that's out here being added or subtracted at the very end, which makes sense because the vertex is now 0, negative 5. 0 on the x, negative 5 on the y. Let's all put a dot at that most important point, 0, negative 5. Draw your axis of symmetry right through it, which is kind of weird because it's the y-axis itself. And let's write down what the axis of symmetry equation is. It's x equals the x value of your vertex, which we could see is 0. So axis of symmetry equation is x equals 0. Now we either need to use an input-output table, an xy table, or the pattern. So it's totally up to you guys. I always go with the pattern. And normally the pattern for the a value of 1 is 1, 1, 2, 4, 3, 9. But this a value is what? What's the a value up here? 2. A value is 2, right? There it is. The a value is 2. So I need to modify this pattern to the new a value of 2. So what does that mean? I need to take that new a value and multiply all the outputs by 2. So my pattern will become 1 times 2 is 2. 2, 4 times 2 is 8. and 3, 9 times 2 is 18. So the pattern is really 1, 2, 2, 8, 3, 18. So if I go to my vertex and I look at my A value, knowing that it opens up, I could use the pattern 1 over 2 up and put a dot right there. I could go back to the vertex and go 2 over 8 up. 2 over 1, 2, 3, 4, 5, 6, 7, 8 up and put a dot right there. And if I did go back to the vertex 3 over 18 up, 3 over 18 up, I'm going to be way off the graph, so it's pointless to do that. Let's map those coordinates over to the other side. And we have our parabola right there through those coordinates. Now, I do want to remind you guys that you could use an input-output table, and what the input-output table actually produces are solutions to the original quadratic equation. As a matter of fact, any graph of any function is really representing the infinite amount of answers that exist to an equation. So if I wanted to, I could plug in a 1, and I could plug in a 2, but without plugging in, if I looked at my graph, plugging in a 1, that would mean that if I go to the x value of 1, what would my output be? What would my y value be? It would be -3. Okay, so if you actually plugged in a 1 into the function and worked out the math, you would get a -3 right there. If I actually went to the function and plugged in a 2 and did the math, 2 on the x, I ended up with a 2 on the y. My answer will be a 2. Okay, but obviously, it's a lot. You actually have to show your work when you're plugging in values, and there's more opportunities for mistakes. So I definitely like the pattern. Let's state everything else that we could. What's the y-intercept of this thing? -5, right? And we could give it in the form of a coordinate, 0, -5. Because after all, to find the y-intercept, we must set x equal to 0. Is this a maximum or minimum value? Minimum. And what is that minimum value? Let's state it in terms of y. -5. Perfect. The y value of your vertex. The domain, ridiculously easy. X equals all real numbers. The range, y is what? Greater than or equal to that minimum value or that y value of your vertex. State the x-intercepts. Approximate if necessary, which I guess we do need to approximate. So what are we going to say? It looks like here's 0, 1, 2, -1, -2. So we're going to say about 1.5 and also -1.5? Mm-hmm. Okay. So that's what we're going to write as an approximation. -1.5 and 1.5. And that's about it, guys. You guys are going to work on the rest of this. There's also a video explaining other of these questions if you're totally stuck. Good luck.